So for exercise 2.3, so we've been asked to do a proof. So the Babylonians, they use 360 to go all the way around. So let's start halving that. So 180 degrees, go halfway. That's not good enough, is it? So let's split the 180 and let's just go a quarter of the way. So we've got 90 degrees. Okay, but we're looking for 45 degrees. So I'm going to have to split that again, and then I will have my 45 degrees. So for my one revolution there, I've halved it. I've halved it again, and I've halved it, so that's once, twice, 3 times. Right, so to get to 45 degrees, I need to take my revolution and multiply it by 1/8. So I need to multiply that by 1/8 to get the equivalent of 45 degrees. Right, so that's obviously used that bit. So the other bit is using trig. Well, so here we can see that we've got something going off in this direction. If it's 45 degrees, we can see that this length here and this length here must be the same. So I can redraw this as a right-angled triangle with some length here, h, the adjacent here, and the opposite here, where the opposite equals the adjacent. Okay. Right, so where does that get me? Let's set h to be, no, let's set an adjacent to be a value. So let's say that adjacent equals 1. So that means the opposite equals 1. Okay, so where do I go now? Well, I've been told to use Pythagoras. So let's use Pythagoras, and Pythagoras tells me that the adjacent squared plus the opposite squared equals the hypotenuse squared. So I have therefore got that 1 squared plus 1 squared equals hypotenuse squared. So I therefore have, I can say that h squared equals 2. Take the square root of that. So therefore I've got h equals root 2. Right. So final bit is what do I want to do? So the final bit is go to my definition of what cos is. So I'll write it in this box here to keep it on the same page. So cos 45 is defined as the adjacent divided by the hypotenuse. Well, I've said that I'm going to let my adjacent equal 1, and I've found that my hypotenuse is root 2. Now they actually give a final answer of root 2 divided by 2. If I times the top and the bottom both by root 2, I then get root 2 divided by 2, because root 2 times root 2 equals 2. So a bit of a squash, but I've done the proof. Not terribly neat though.